This image is not a photograph in the usual sense. It's not a nebula, not a star, and not even an object you can simply point a lens at. Before you is the center of our galaxy, the place where space stops being just a background, where time behaves differently, and where reality itself starts to glitch. Here, light bends. Here, distances lose their meaning. And here lies an object that cannot be seen directly, but can be detected by the way it breaks everything around it. In 2022, humanity saw the first ever image of a black hole located at the very heart of our galaxy. Its name is Sagittarius A star. But the strangest thing about this story isn't the image itself. The strangest thing is its shape, its structure, a glowing ring, brighter in some places, dimmer in others. Because all of this was already known. These forms were predicted more than 100 years ago by a man who had never seen a black hole. And what's more, he even doubted that such objects could exist at all. His name was Albert Einstein. In his general theory of relativity, Einstein described the universe in a way no one had before him. 100 years later, humanity built a telescope the size of a planet, looked into the center of the galaxy, and saw what the universe had been hiding all this time. And this is only the beginning of the story. Want to know what kind of telescope that was and other interesting details? Then listen and watch. Sagittarius A star is a supermassive black hole located right at the center of our galaxy. According to the latest data, it's about 27,000 light-years away. Its mass is roughly 4 million times that of the Sun. That means an amount of matter millions of times heavier than our star is compressed into a volume comparable to our solar system. And yet, it's relatively compact. By cosmic standards, Sagittarius A star is actually smaller than another famous black hole, the one in the galaxy M87, which was photographed first back in 2019. And here comes the paradox. Sagittarius A star is much closer. It's literally ours, the galactic center around which hundreds of billions of stars orbit, including our Sun. But photographing it turned out to be far more difficult than capturing the more distant and more massive black hole in galaxy M87. Why? The problem is that Sagittarius A star is not a static object. Gas and dust around it whirl at enormous speeds, close to the speed of light. The structures we see around the black hole change literally within minutes. Imagine trying to take a photo of a swirling cloud of smoke. But this smoke is 27,000 light-years away, spins at nearly the speed of light, and constantly changes shape. Any ordinary camera would capture only a blurry smear, just noise, chaos. To freeze such an object, humanity needed an instrument that, for a very long time, simply didn't exist. So scientists took an insane step. They decided to build a telescope the size of the Earth. The Event Horizon Telescope, or EHT, is not a single device. It's a network of 8 radio telescopes scattered across the planet, in Chile, Hawaii, Antarctica, Spain, and other locations. All of them work together synchronously, acting as one gigantic mirror thanks to the principle of interferometry. Each telescope captures radio signals from the galactic center. The data is recorded with extreme precision, synchronized by atomic clocks. The volume of information is colossal. Petabytes of data. It couldn't be sent over the internet. Hard drives had to be flown across the globe by plane. Years of observations, years of processing, supercomputers, extremely complex algorithms, and finally, an image. But when the scientists saw the final result, they didn't just feel excitement. They felt astonishment. Why? Because the image turned out to be too familiar. A bright glowing ring, a dark area in the center, a symmetry in brightness. One side of the ring is brighter than the other. That's exactly how, with mathematical precision, a black hole should look according to the equations of general relativity. But those equations were written in 1915, 100 years before the first image, decades before radio astronomy even existed, half a century before the first satellites were launched. Their author, Albert Einstein, a man who never saw a single black hole and never even called them that. What Einstein predicted 100 years ago. In his general theory of relativity, Einstein proposed a radical idea. He said, "Gravity is not a force in the usual sense. It is the curvature of space and time. Massive objects bend the very fabric of reality. And everything around them, planets, stars, even light, follows those curves." From this theory followed something terrifying. If enough mass is squeezed into a small enough volume, the curvature becomes infinite. A region appears from which nothing can escape, not even light. That's how the idea of a black hole was born. But most importantly, Einstein calculated how light would behave around such an object. He showed that around the event horizon there should appear a photon ring, a region where light literally orbits the black hole in closed paths. And that very ring is what we see in the image of Sagittarius A star. And here's the key thing to understand. We don't see the black hole itself. That's impossible. A black hole doesn't emit light. It doesn't reflect it. It devours it. What we see in the image is the shadow of the event horizon, the boundary beyond which space and time change forever. We see the light from the gas swirling around it. We see how gravity bends the paths of photons. We see the influence of the object, not the object itself. It's like trying to see the wind, not by the wind itself, but by the way it bends the trees. And that's exactly why the image of Sagittarius A star is so important. This picture is not just a pretty image. It's an experiment conducted under extreme conditions, a test of general relativity in the place where it should have failed. But it didn't fail. Einstein was right. Again. This means that his model of gravity works. Space and time really do curve. Black holes exist exactly in the form he described them. And now, with such images in hand, scientists can test alternative theories, look for deviations, and perhaps one day come closer to a quantum theory of gravity. Final, the heart of the galaxy. Sagittarius A star is not just an object. It is the anchor of our galaxy, the point around which the entire Milky Way revolves. Today we know that almost every large galaxy has a supermassive black hole at its center. Perhaps it is these very black holes that shape the structure of the universe. Perhaps without them, galaxies simply could not exist. 100 years ago, one man wrote down equations. Today, the universe has confirmed them. And perhaps, looking into this dark spot, we will one day understand what space, time, and reality truly are at the deepest level.